What's going on, everyone? In today's video, we're going to be continuing the series of an interactive tab bar within SwiftUI. In today's video, we're going to be focusing on how to have in programmatic scroll an automatic async function call within a SwiftUI view. You can imagine if we go to this detail view here, we can still pop out of that detail view, hit the button again, and then hit the tab item again to refresh for more news articles, for example. And of course, this code will be on my GitHub, which I will link below in the description because some people were saying that it wasn't in the description. So without further ado, let's get started on how we can implement this within SwiftUI and have some fun here. All right, and here we are in the application, and I've changed around a lot to where it actually has an API service where it gets latest news from, and it's kind of queried just to show like Apple News. So here you can see that we have some dummy data of just some, well, not dummy data, but it's actual news sources. But in our case, we're just not really caring about the news sources, just to show off some stuff here within the app. And most applications, especially like Twitter and I believe maybe Instagram, you have the opportunity to actually select this tab view item again for the content to actually scroll all the way back up to the top and then actually refresh based upon content size. Currently in iOS, for at least lower deployment targets, from what I know, between 18 and below, this isn't possible, and actually that's what we're going to be focusing on today, on how we can make this possible. So within the article view here, this is of course where all the articles are held, and within here I've just set up some states here to actually calling some detail views and some asynchronous functions. And then remember that we have already a view that is a tab view item wrapper. So within this wrapper, it manages the light of the actual navigation paths of a view that it's actually installed on. And within here, we're just using some stuff within Notification Center to detect when a tab view item to change or get selected again. Within here, you can already kind of notice how there's kind of an annoyance where how can we have this interact with this view and then still have it be able to pop to review it and be able to handle certain edge cases as well. So thankfully, if I can look back over here, I haven't installed it. So as you can see, we have a scroll view and it just has some states within here. Now, when we're loaded, we're showing this article list view, which is just the lazy VStack of these article cells. Since it's above the scroll view, we can install a scroll view reader within this view or above this view that we have within the wrapper view, and then have it manage the likes of the content size or the offset position of the scroll view content and do some coordinate math. So within here, we can go ahead and go back up to this view and we can say we need a scroll view reader. So scroll view reader will always pretty much handle the likes of where the scroll view that is this child view needs to scroll to. So if we wanted to say, hey, scroll to this cell, as long as it has an identifier for that cell, it can scroll to that cell and present it on display. But in our case, we are just passing this entire content. We don't have a way to really say where, or at least I want to say right now, we don't have a way for it to say like, hey, scroll to the top. So how do we do it? Of course. Awesome. So now that we pretty much have everything laid out, we have the actually checking for navigation path. Next we need to do is actually check the scroll position of this view. And in our case, since this is actually installed right above the scroll view, we need to be able to check the scroll position, not of the scroll view, because the scroll view itself isn't scrolling. The content inside of the scroll view is, or it's offsetting off the screen. Extension view. Okay, so an extension of view, we're going to do something within the actual content view. We're going to say func content offset observer, and we're just going to return some view, which will be self. And what we need to do behind the scenes of the self view here is we need to go behind the background and actually measure, based upon the actual geometry reader, where the content is positioned or how much content size there is within the scroll view. So we can do that by going background, and then we're going to go geometry reader content. We can bring in the geo, I just like to call it geo, or geometry, we just leave geometry for now. And then we need to also do a few things here, but we have pretty much the basic setup right now. All right, and now within this view as well, we're gonna also have something called a content offset value. And that's gonna be a binding of a, let's just call it a binding for now. Oh, actually, no, let's just say value of a binding CG float. What's gonna end up happening is that we're gonna create a preference key. We're going to have geometry reader update that preference key within the view, have this content offset value measure and get the actual view of the change of the preference key. Struct content offset, offset observer key, preference key, and the preference key is somewhat still something I'm trying to understand, but I believe it's just your typical way of having an environment value that can communicate with other SwiftUI views and then be able to update values based upon it as well. The default value be, well, we need to have a type alias first of the value. So it's public type alias, and we're gonna have CG float of a CG float, and then we're gonna say CG float, and then it needs to start off with 0 at start. So that will be that we're at the top of the view, and then we need to actually do some math here to make sure that this is always returning to 0, because sometimes you'll throw like a large float number. And then we need to say, also say reduce, and which that's going to be able to get the value of the closure. Then we're going to be able to say value plus equals next value. So that's going to be firing based upon this closure, which will return the CG float. And let's say what's going on here. We need to call this function. Whoops. Awesome. So now that we have pretty much the geometry reader set up, the reason we have these two as separate functions is because one is going to be installed within the actual scroll view, and then one's going to be installed outside of the scroll view. So right here within geometry reader, we're going to say color.clear.preference key, or then we're going to get the preference key. We're going to say content offset preference key itself with the value being the geometry reader dot frame, and then we're going to want to also pass in a coordinate space. We're going to say coordinate space, which is the view's coordinate space based upon the dimensions and points that it can measure from, and then we're going to just say that this is the scroll view content space, or we can name it whatever you want to. And let's see, we actually forget that this needs a name method or label here, or named, or it's name. Okay, so name scroll view with the string, and then we need to go back up here to where the value for the frame, we need to say scroll view, well that's new, but named, and then as you can see it's already pretty much smart. We can bring that in, and then of course now we just need to get the value of what's the min y. So that's the lowest y value of the actual geometry reader. So now within the content offset value, we need to monitor when the concept preference key changes. So within here, we're going to say, or it already did it, on preference change of the content offset preference key that self, and then we're going to get that CG float value. Let's say offset value in, and then we need to update that binding. I want to say we probably want to also keep this on main thread. So I'm going to dispatch queue.main.async, and value.wrapped value should also equal that offset. Awesome. All right, now back to our articles view. So as you can see on the right side, we have the content offset observers, and then on this side we have the actual content view. So I already have a property up here, a state property. It's called the content offset. And what we need to do first is to actually monitor the offset of the content within the scroll view. So I created a Z stack for this case since we have some switch statements, and then we can go ahead and just get the content offset observer and plug that here to where now it's going to monitor the offset, or of course position of things within the geometry reader, the background of this Z stack. Content offset value, and then get the value of the content offset. Awesome. So now we have this property here that will get the actual value, and then this property here that will actually observe the value. So now I want to say that we can now say on change of the, let's say the content offset, and this is an old method, we can say print new value. Awesome. So now when we scroll, as you can see, we can scroll the content and we can see that we're offsetting pretty far down the actual stack. So it's actually clean up this very large looking float number. All you have to do is just go back to the content offset value method within the extension here, and then make sure we do a min property, which is going to get the lesser of two compared values. And in our case, we don't want to have such a large number. These methods get a little bit confusing in my opinion. 0, perfect. So now 0 means that we're at the top of the view. Now we can go to the actual tab view item wrapper and have it manage the likes of the content offset based upon the CG float value. So now remember that number 2 was to actually check the offset value or the scroll position within of the content view, where we're going to have a binding of the content offset. And maybe you want to make this a little bit safer, maybe like an object, or maybe like a model, but in our case we're just going to have some binding properties. So CG floats. So now we're going to go ahead and get this content offset in. Content offsets, bring that up to the top of the wrapper arguments. Awesome. So now that we have this in, now that we can actually checking for the navigation path, Now we need to check for the actual scroll view. We need to say else if content offset equals 0. When we have the actual content, we are pretty much want to tell the scroll view reader where to scroll to. For this content itself, we can also say a content offset observer. Within this observer, we can have it to where we can give it an ID, and that'll be the ID of the view we want the scroll view to scroll to. Then have an ID of content view, or we could say top of content view. Else if content's offset equals 0, we need to say proxy dot scroll to ID, which is of a hashable value of a string, anchor point dot top. Keep going, offset. And if we go press articles again, okay, it's not working. So we need to figure out why this isn't working. Okay, so I see I made an actual logical error here. So we're going to say else if not content offset equals 0, then we need to tell it to scroll. Keep scrolling. We're all the way down. Articles, pop to top. Awesome. So as you can see, keep scrolling. If we go to a navigation stack, tap that here, pop to top. Awesome. Now, if we want to make it, of course, a little bit nicer, because it definitely is a little bit just immediate, we can actually throw in a with animation here. Come on. Say we go in the stack, go out, scroll to top. Awesome. Now, as mentioned, the next step would be to actually refresh the content when the content view has like an asynchronous function, for example. So for scroll views, there is a method within here called refreshable. And if you're familiar with that, it's similar to task, but in our case, the view is refreshable, meaning that it can actually refresh for more content from the actual server or other API backend that you have. In our case, we already have the refreshable action within the scroll view. So now we can go back into the tab view item wrapper view, which is now coming under a terrible name. And we want to look for a refresh action within the environment property here. And then say refresh action. And that's actually going to be optional because sometimes the refreshable action isn't within the views, and we can handle that as well. And we want to say that for that to happen, we probably want to have something where we have a task actually kick off, because let's say in some instance we actually have this happen and it comes canceled. We also need to be able to handle those cases as well. So we can have a property within this, or state property within this wrapper, say state private var is refreshing. So we introduce now a function here that is a task, and then we have an ID priority, which I'm going to explain in a minute what this does. And it says when a views appear with specific value changes, we really want this to happen when this value changes. So we want to say when it refreshing changes, if is refreshing, okay, and we need to say if it is refreshing, because all we're going to do now is just update this property and it's going to call off this task. We need to say await refresh action, and this is going to be optional. Self.is refreshing is false. We can say else if not is refreshing, self.is refreshing is set to true. The environment property within a wrapper view cannot directly interact with it since it's installed within it. So we have to actually move this refreshable action, as you see here within the articles view, but like right below the wrapper view, so that the wrapper view can interact with it within its environment property, and the scroll view can still interact with it as well. So if we scroll down and go through some stuff, let's hear about, I don't know, the new Pixel 9, even though some of these images aren't loading. And we can see that within here, we're in the content view or detail view. We can hit the articles button or tab bar item back, hit it again to scroll up, then of course hit it again to actually refresh the view. And that is all to it. And if we keep hitting it now, as mentioned, since we have these instructions and conditionals set out, this always defaults that to the refresh view. So even if we go down, it can scroll back up, or if we go back up here, it can scroll back up and keep refreshing the views as we go. So that does it for today's video. If there are any more suggestions or questions regarding this implementation, then please reach out to me on Twitter or even on this YouTube channel. Thank you for watching. If you consider subscribing, please do. And yes, leave behind any questions, comments, or maybe some mistakes I might have made within the code, and how we can possibly make this even better than what I have it at now. Thanks for watching, and have a good day.